Hi, my name's Beeton. We're in the Bunya Mountains at the Genestream Sculpture. For years I'd created art on the ecology, geology and deep time history of natural systems, and I'd also been working on the Genestreams project. The two were running in tandem, and I never believed that there would come a point where I'd be able to bring all of this together. That was until Arnie Carol Peterson asked me a question: was there some way that we could bring together the conservation work in an area with work that was being done on the scientific communities and research in the area, as well as the culture of the area. So for years I worked through that problem, how to bring a public artwork together that would address all of those different components in the one sculpture. And it was at that time that I realized that if I created an evolutionary tree of the area, where I addressed all of the deep time story of the shared ancestry of species on the base plate of the sculpture, and told the story of the science of the region on the inside of the sculpture, and the culture of the region on the outside of the sculpture, it would be a way of bringing that question together, all of those components. So in this sculpture, we see an example of how we bring together the gene streams of species with the ecology, geology and deep time history of species on the inside of this sculpture that you walk into. A gene streams represents the sum total of the gene pool of a range of species. Gene streams travel across the globe through deep time over hundreds of millions of years, changing into a myriad of species, from ancestral species to descendant species and so on through deep time. That's why I chose the word gene streams to describe this form of public art and this form of science communication. So let's pretend that I'm somebody that's approaching the Genestream Sculpture for the first time, and I'm curious. I don't know what this is all about. Clearly there's a walkway into it and there's an invitation. So I'm going to walk into it. Now, bearing that in mind, this all looks pretty unusual. I'm going to tell you what this actually means. I am representing the whole of humanity as I enter this sculpture. Anyone that enters the sculpture represents the whole of humanity. And each one of these panels represents a different species. It's color-coded to show that the animals are in orange and the plants are in green. So, being an animal, I can see that this continues on. And what does that mean? This is a phylogenetic tree for the base plate, so it's a detail of the tree of life, and it's going to show me where I share common ancestry with these other species. So if I walk back in time, I can see, if I turn around, so I can actually read these unusual words, these are the periods of geological time. This is the Jurassic period, from 201 to 145 million years ago, and if I follow that back around here, you can see just here it's joined to this line, and this is the quoll. Here we can see fantastic scientific illustration by Marley Moyer of the spotted quoll, and a wonderful photograph by Steve Parrish. So this is telling me that at this point in deep time I share a common ancestry with the quoll. But you see, then they go back together. The ancestor of both myself and the quoll go back to, it says Triassic. That's 251 to 201 million years ago. So this is the first period of time when dinosaurs lived. And if I follow that back around to this point, you can see this is where myself and the quoll, the common ancestor of those two, share a common ancestor with this next species, and that is the echidna. Here you can see the illustration that myself and Marley Moyer did of the echidna, and we can see a wonderful photograph of the echidna by Steve Parrish. So the common ancestor of all three of these now goes back to this period of time here. And let's go and check what it is. It's the Carboniferous period. So that is 358 to 298 million years ago. And that's at a time that we find fossils of dragonflies the size of eagles, spiders the size of your head. And at that point, we're sharing a common ancestor with the carpet python, an illustration that Marley Moyer and myself did together, and so on. And that is how we plot back through time this story of the shared ancestry of a whole range of species until we get right back to this point here, where we can see beyond the Ediacaran, somewhere deep, deep within the Precambrian, the plants and the animals share a common ancestor. And at that point, we call this, going back even further than that, all the way back to the origin of life on Earth, Luca, the last universal common ancestor. And all of these species are found in the Bunya Mountains. Species that we've selected, very special species found in the Bunya Mountains, many of whom we often focus on threatened and endangered species. So when I leave this sculpture, I'm leaving with this incredible awareness of the shared ancestry of myself with all of those other very special species that we share this planet with in this incredible environment that we call the Bunya Mountains. I'm going to show you how to use this sculpture. Now, looking at the base plate, we find the Cambrian period, for example. It says Cambrian, and then next to it, it says the date. It says, in this case, it runs from 538.8 million years ago to 485 million years ago. And then what I do is I look up onto these panels and I look for the Cambrian map. It says Cambrian at the top. Cambrian at 540 million years ago. And that's telling me what the world looked like in the Cambrian period. And then I might go down again and I might look, say, at the Silurian period. And it tells me the Silurian period, which is later on, is 443 million to 419 million years ago. And I look up again, I look around, there's the Silurian period. And I can see Australia at the time is on the equator or thereabouts. Silurian period, 438 million years ago. So that is how we use this connection between the base plate, which is, for all intensive purposes, a phylogenetic map, with the artworks that I've created in collaboration with scientific illustrator Marley Moyer and a range of other artists. On my travels in Western Australia, when I was in the town of Albany, I met an artist called Jenny Wilson who introduced me to the process of eco-dyeing. And you can see that the sculpture is covered in the process of eco-dyeing. It's literally everywhere throughout the sculpture. The reason that I wanted to use eco-dyeing, and I want to use eco-dyeing in all of the sculptures, is because it reminded me of fossils of the past. And to me, it was an insight into what the fossils of our time would be. That's the fossils of the future. So amongst the many things that this sculpture celebrates, it's celebrating the fossilization of our time into the future. A lot of people, when they come into this sculpture, look at the word Luca and they don't know what it means. It means last universal common ancestor, deep within the Precambrian. Each one of these brackets of time is measured in millions of years. So that small yellow section is the Luca, that shared ancestor that all plants, animals, fungi have together. And then you can see a phylogenetic tree breaking apart in different directions. The orange color represents the animals and the green color represents the plants. And so we move through that into the Ediacaran. The whole Luca period jumps not just millions, it jumps billions of years. But the Ediacaran, Cambrian, Ordovician, and so on, to give you a brief understanding of that, the Cambrian is when we see the evolution of eyes and the radiation of many forms of life. The Ordovician, it's now believed that perhaps Ordovician is when the first plants come onto land. Australia at the time had a seaway in it, and the rise of the McDonald Ranges. Silurian is really where we see the plants coming onto land, and Devonian is where we see our ancestors coming onto land. And the first forests, Devonian, is where you get massive funguses as well. And then we have the Carboniferous period, and that's where giant forests are, and there's dragonflies the size of your head, there's millipedes the size of cows. Extraordinary time. And the Permian brings an end to that. The Permian, at the end of the Permian, we have the massive extinction event. There's been many mass extinctions, but the Permian was the biggest, and that's where we have something like 95% of all life disappearing on the planet due to massive volcanism in the Siberian traps that lasted millions of years. And from the Permian, we move into the Triassic, and this is the beginning of the dinosaur time. So everything from the Cambrian to the Permian is Paleozoic. Triassic, Jurassic, Cretaceous is known as the Mesozoic, and that's all the time of the dinosaurs. So Triassic, Jurassic, Cretaceous, the end of the Cretaceous, the asteroid hits the Earth, and then we move into the Paleogene, the Neogene, and the Quaternary. And that is a very, very brief story of the deep time history of shared ancestry of the planet. The shared ancestry of all of these species that the sculpture represents is found within those periods of geological time. And right on the outside, that entrance point, that's where the humans exist. So when you walk into the sculpture, you represent the whole of humanity. Throughout this entire sculpture, you'll find many little details. For example, here we can see Australia breaking away from Antarctica and the formation of the Southern Ocean. Australia was the last of the continents of Gondwana to break away from Antarctica, and I just find that to be an incredible story. Everywhere you look in this sculpture, there's small little details that'll tell you more about the deep time history of Australia and the formation of landscapes and the evolution of species. The story of the Bunya Mountains is the story of volcanism, and so throughout this artwork I've told the story of the formation of the East Coast, and a strong part of that story is the story of the movement of Australia as it drifted north over a hotspot. It's believed actually there were several hotspots, and as it drifted north intermittently, this hotspot erupted and you had another volcanic episode. So there are volcanoes much further north from the Bunya Mountains and much further south, including all the way down to Hanging Rock. If you know the movie Picnic at Hanging Rock, it's all part of the same story. It's all interconnected. So throughout this sculpture, you'll find lots of small details that tell the story of those incredible connections of the geological and volcanic history of the east coast of Australia. I love featuring sequences in the artwork that tell the story of deep time over millions of years in a sequence of images. So you can see the hotspot that formed the volcanism, and as Australia moves north, it creates more volcanoes. And so it's now down here, and that's the idea that in the future, the very same hotspot that is responsible for a lot of the East Coast volcanism, all the way up to here, will one day form a volcano in the northwest, potentially of Tasmania. This is another way of thinking about a phylogenetic tree. So in this one, time is going in this direction, and wherever you see it breaking into two, that's where we see a common ancestor breaking into two different descendant groups, and the names of them at the end. So phylogenetic trees to me are absolutely wondrous, and I've spent many, many years drawing them and fascinated by them, which is the foundation for the Genestreams project. As the base plate is a phylogenetic tree exhibited in the round, so too we can see another example of a phylogenetic tree exhibited in the round. And interestingly, above it, I spoke about the deep time history. It takes a long time for this level of speciation to occur. You could see we start with, say, one species, say here, that breaks into two different groups and so on, and this is the result at the end a huge amount of evolution. What does that tell us about the deep time history of the planet? It tells us that the planet's moved around a lot. In this particular case up here, this small little detail that most people maybe won't see, this is actually the ice sheet during the Carboniferous period, when dragonflies were the size of eagles and spiders were the size of your head. This panel represents the quoll. In it you can see some of scientific illustrator Marley Moyer's wonderful illustrations of it. We also have a detail from Steve Parrish. But what you'll see over here is that Marley Moyer and I have done the research as often as we possibly can to show through the Linnaean system of classification where the quoll exists within the tree of life. And so the Linnaean system of classification is really a way of locating any species within the tree of life, and we also show its status. That's its conservation status, and in this case it's invulnerable. So very, very important to protect this species. I remember a story by Gary Muir, who's one of our team members who did the research on the base plate to locate the shared ancestry of the species. He set up a camera, and because he was looking for the quoll, he'd found footprints. He found a quoll running along it, but just behind it there was a feral cat, and I believe all they found left after that was the head of the quoll. So very important to protect these species.